Kia ora, Year 12 and 13. This is question 3D, not 3D and E, from last year's differentiation exam. I've decided to split this into two separate videos because even though it's a merit question, it's quite involved and I want to go through it pretty slowly. So here comes the question now. It's a rates of change problem. So pause the video and read through it and just work out all of the information that you've been given. Okay, so let's start at the start. The elevator is rising at a constant rate of 2 meters per second. So we can write that as dH by dt is equal to 2. And Sarah is stationary. She is watching the lift go up from a point 30 meters away from the base of the elevator shaft. So it's really important that when we do these questions, we think about what's changing and what's constant. The 30 is constant, so we can already start to think about drawing a really bad right angle triangle, but there you go. So we've got 30 here, and we've got theta here, and we've got h here. We're told that we need to find out the rate at which the angle of elevation is increasing when the elevator floor is 20 meters above her eye level. Now they've put 20 meters on that diagram, and I think that the first thing you need to do when you do one of these is to forget about that information until the end of the problem. So that's going to be the last thing we use to solve. To start with, we're going to say, what do we want to find? Well, we want to get d theta by dt when the height is 20. So let's look for a really basic trig relationship between theta and h. We'll go back to our triangle. So over here, we can say tan theta is equal to h, opposite, over adjacent, over 30. So h is equal to 30 tan theta. So that's step one. We've linked those two variables. Now we come back to d theta by dt. We're going to use the chain rule to say that d theta by dt is equal to d theta by dh times dh by dt. Right, now the only trouble we've got is that when I look back over here at h equals 30 tan theta, I can differentiate that, and that'll give me dh by d theta. It won't give me d theta by dh directly, but let's do it anyway and see what we can do with it. So we get dh by d theta is 30 sec squared theta. How can I figure out d theta by dh? Well, there's a really easy way to do that, which is to remember that derivatives work in some ways as fractions, and it always feels a bit dodgy to say that, but it works. So dy by dx is equal to 1 over dx by dy. So that's how we can get d theta by dh. So I'm going to do that now on the next slide. Right, so here's my triangle. Here's theta, and this side is 30. Now we've got h. d theta by dt is equal to d theta by dh times dh by dt. Well, we know that dh by dt is 2 because the lift is rising at a constant rate. And we had dh by d theta was 30 sec squared theta. So d theta by dh is 1 over that. It's 1 over 30 sec squared theta, and that gives me cos squared theta over 30. So I can now take this and substitute it into here, and I get 2 cos squared theta over 30, which is cos squared theta over 15. So I should be feeling pretty happy at this point, because I've got an expression for d theta by dt. There's just one thing left to do. We need to figure out when will h be 20. So h is going to be 20 when there's some particular value of theta. So I want you to try and do that last bit on your own. Okay, so when is h 20? So go back to my right angle triangle. I'll do that on the next slide. So when h is 20, this is what we get. 20 is equal to 30 tan theta. tan theta is equal to 20 over 30. So solving that, theta is equal to tan inverse of 2/3. And that gives me 0.588 something. So keep that number in your calculator. So tan inverse of 2/3. And now we need to find d theta by dh. So d theta by dh, we worked out on the previous slide, was equal to cos squared theta over 15. So at theta equals 0.588, we can substitute that in, and we get 0.832 ... squared over 15, which gives me a final answer of 0.046, and my units is going to be radians per second. Now up here, that should say d theta by dt and not d theta by dh. Okay, so that's the final answer, and that's, if you get the whole way through it, that's a merit question. All right, thanks for watching. Make sure you go through that one independently on your own. So leave it a couple of days and then come back to this question, because it's a really good example of a straightforward rates of change problem.